Hello science fans. Today, we're exploring Yellowstone National Park, a place of stunning geysers, vibrant hot springs, and wild bison. But beneath this beauty lies something even more powerful, the Yellowstone supervolcano, one of Earth's largest volcanic systems. While disaster movies love to dramatize it, the real story is far more fascinating, and less terrifying. Yellowstone isn't a ticking time bomb, it's a complex geological engine powering the park's geysers and hot springs. Studying Yellowstone helps us understand the forces that shape continents and build mountains. Scientists monitor subtle shifts beneath the park, gathering data that protects people worldwide. Yellowstone is a living laboratory, revealing how our planet changes from the inside out. The real adventure isn't in what if, but in what is, what's happening under the park right now, and what does it mean for us. Let's dive in and explore the science behind this sleeping giant. To truly understand Yellowstone, we need to go back, way back in time, to an era when the land looked nothing like it does today. The park sits inside a massive caldera, a giant volcanic crater, formed by a colossal eruption 631,000 years ago, one of the largest eruptions in Earth's history. In fact, Yellowstone has experienced 3 super eruptions over the past 2.1 million years, each one dramatically reshaping the landscape and leaving behind scars that are still visible today. Deep below the surface, a volcanic hotspot acts like a blowtorch, melting rock as the North American plate slowly drifts overhead, fueling the region's intense geothermal activity. Magma collects in a complex system of underground reservoirs, not just a single giant pool, but a network of chambers that feed the park's volcanic features. The uppermost reservoir powers Yellowstone's famous geysers and hot springs, sending jets of steam and water shooting skyward in spectacular displays. Most eruptions here aren't super eruptions but slow-moving lava flows that have gradually built up the park's plateaus and rugged terrain over thousands of years. The heat from the hotspot fuels everything on the surface, from the iconic geysers to unique winter plants and even the wildlife that thrives near the warmth of the hot springs. Yellowstone's story is one of cataclysmic change and gradual rebuilding, a living connection to Earth's fiery heart, where destruction and renewal go hand in hand. It's a powerful reminder that our planet is dynamic and ever-changing, with immense forces just beneath our feet, shaping the world in ways we can barely imagine. That's what makes Yellowstone so unique, a place where you can witness the raw power of nature and the ongoing story of our planet's creation. So, how do we know Yellowstone isn't about to erupt? The answer is simple: we watch it, constantly, and with incredible attention to detail. Yellowstone is one of the most closely monitored volcanoes on Earth, and for good reason. Scientists at the Yellowstone Volcano Observatory use a sophisticated network of instruments to monitor the volcano's vital signs, 24 hours a day, 7 days a week. Their work is ongoing, no matter the season or weather. They track ground movement with high-precision GPS and satellites, detecting even the tiniest changes in elevation, sometimes just a few millimeters. These subtle shifts can reveal a lot about what's happening deep underground. Seismic activity is another key sign. Yellowstone experiences up to 3,000 earthquakes a year, most too small for people to feel, but each one is carefully recorded and analyzed. Scientists look for unusual patterns, like swarms of stronger or deeper quakes, which could signal magma, movement, or changes in the underground plumbing system. Gas emissions are also closely monitored. Changes in gases like sulfur dioxide or carbon dioxide can indicate new magma rising toward the surface, or shifts in geothermal activity. All this data feeds into an early warning system, allowing scientists to spot changes before they become dangerous. It's a real-time safety net for everyone in the region. In a way, it's like giving the volcano a regular checkup, measuring its heartbeat, temperature, and breathing, so nothing goes unnoticed. The goal isn't to predict eruptions years in advance, but to detect immediate warning signs and respond quickly if anything unusual happens. This constant vigilance keeps visitors, park staff, and nearby communities safe, providing peace of mind for millions who come to experience Yellowstone's wonders. Yellowstone's breathing, the subtle rise and fall of the land, the shifting of gases, the tremors deep below, is closely watched every single day. That's how we stay ahead of the giant, always alert, always learning, and always ready. To keep things clear, the USGS uses a color-coded alert system for volcanoes, like a traffic light. This system helps both scientists and the public understand the current state of volcanic activity and the potential risks involved. Green means all is normal. Yellowstone is at this level almost all the time. It indicates that the volcano is in a typical non-eruptive state, and there are no immediate signs of danger. Yellow signals elevated unrest like earthquake swarms or ground changes. Time to pay closer attention. This level suggests that the volcano is showing signs of increased activity, but an eruption is not necessarily imminent. Orange means heightened unrest or a small eruption underway, prompting serious concern and preparation. At this stage, scientists are closely monitoring the situation and preparing for the possibility of a larger eruption. Red is the highest alert. A hazardous eruption is imminent or happening. This level indicates that a major volcanic event is occurring, and immediate action is required to ensure public safety. For Yellowstone to reach red, scientists would need to see strong, shallow earthquakes, rapid ground uplift, and major gas changes, all at once. These indicators would suggest that magma is moving towards the surface, posing a significant threat. These alerts are based on hard data, not speculation. Scientists use a variety of tools and techniques to monitor volcanic activity and ensure the accuracy of their assessments. A red alert would only be issued with clear, undeniable evidence. This ensures that the public is only alerted when there is a genuine threat, preventing unnecessary panic. The system ensures emergency managers and the public get timely, accurate warnings. This allows for better preparation and response to potential volcanic hazards. It's a way to translate complex science into simple, actionable information. By breaking down the data into understandable alerts, everyone can stay informed and take appropriate actions. The alert system is our early warning, so we're never caught off guard. It provides crucial time to implement safety measures and evacuate if necessary. That's how science keeps us safe. By staying vigilant and informed, we can mitigate the risks posed by volcanic activity and protect our communities. Not all Yellowstone eruptions are catastrophic. The most likely event is a hydrothermal explosion, steam blasts that create craters but don't involve magma. Next is a lava flow. Slow, thick lava oozes out, altering the landscape but staying mostly within the park. These have happened dozens of times with limited impact outside Yellowstone. The super eruption scenario, the one that grabs headlines, is extremely rare. It would send ash and gas high into the atmosphere with global consequences. But scientists see no evidence Yellowstone is primed for such an event. The magma reservoir is mostly solid, not a ready-to-erupt tank. The real story is about understanding all possibilities, and right now, the giant is quiet. Yellowstone's most likely future is peaceful slumber. Imagine a red alert is issued. An eruption is imminent. Immediate, organized evacuations would begin, moving tourists and residents out of harm's way. The biggest threat, volcanic ash. Even a small eruption could blanket hundreds of square miles. Ash can collapse roofs, halt transportation, contaminate water, and devastate agriculture. Health risks are serious. Breathing ash can cause major respiratory problems. People would be told to stay indoors, seal up homes, and wear masks, if outside. Hospitals would brace for a surge in patients. Air travel would stop, supply chains would be disrupted, and the global economy would feel the shock. A Yellowstone eruption wouldn't just be a local crisis, it would ripple across the world. It's a powerful reminder of how connected and vulnerable our modern world is. Nature's power can reach us all. After a red alert, scientists would work around the clock, shifting to real-time analysis and forecasting. The Yellowstone Volcano Observatory would become the world's information hub, with experts worldwide collaborating. They'd use every tool, GPS, seismometers, gas sensors, computer models, to predict where and how the eruption will unfold. Forecasting ash cloud paths would be vital for aviation and public safety. Seismic tomography would help image magma's ascent in real time. The final phase before eruption could be terrifyingly fast, weeks, not years. That's why continuous monitoring is essential, to give people precious time to evacuate. Science's job is to turn data into life-saving warnings, even when the clock is ticking. In a crisis, every second counts. Should we live in fear of Yellowstone? Absolutely not. Its story is about discovery, preparedness, and our relationship with a living planet. Monitoring gives us time to act, not just for Yellowstone, but for other rare disasters. It teaches us to build resilient infrastructure and cooperate globally. Yellowstone is a real-world drill, keeping us ready for the unexpected. Trust between scientists and the public is vital. Clear communication replaces fear with knowledge. If an alert ever comes, people will know to listen and act. Yellowstone is a place of wonder and a window into Earth's power. It reminds us to respect our dynamic planet and to stay curious. And remember, scientists are always listening to the heartbeat of the giant.